Hello guys, welcome back to the channel which is All Nighters. Not able to understand the basics of data structures? Don't worry, you are at the right place. We have made data structures so simple for you. Welcome to our channel. If you are new to this channel, please subscribe, and we have created this type of animated video for the first time. So please tell us in the comment section, how is it? Let's start. In today's tutorial, we will be understanding the linked list. Before going into the details, the first question that comes in mind is, why we need linked list when we already have arrays? Well, there are many reasons. In arrays, we have to tell the size when we are declaring any array. For example, this. So it can overflow when we want to store more in the array, or sometimes some memory gets wasted when we have less data. Insertion and deletion problem, which takes order and complexity in arrays. If you want to insert an element x at some index, say 4, in the given array, so what happens is you create an empty position at index 4 by right shifting all the elements after index 4 by one position, and finally you insert at the index 4. Final array looks like this. Similarly, while deleting again, say you want to delete the element at index 4. Again here, first you create a space at index 4 by deleting that element. The array looks like this. And now you have to fill the empty space by left shifting all the elements after index 4 by one position. Final array looks like this. So you have seen that insertion and deletion is not a very simple task. It disturbs the position of many elements in the array and takes order and complexity. Basically, we are not saying that linked list is the best. In some cases, linked list is more efficient, but in other cases, array may be more efficient. Mostly, what we have seen is linked list provide dynamic size, provides faster insertion and deletion without affecting the entire structure. Bonus tip for you guys: if you want to insert and delete at the end or beginning, go for linked list. That would be order 1 complexity. So far, so good. Let's jump right into some complex topics. Let's see the structure of linked list. Well, this is a typical structure of linked list. For each node of the linked list, we would be storing the data as well as the address of next node. In this way, linked list data structure is implemented. Let's understand it with the help of a pseudocode of the class. We are using Java here. Well, the first attribute is data, for storing the value of that element. The next attribute is next, of node type, which would store address of the next element of the linked list. And then is a constructor, insertion in the middle of the linked list. Well, take for instance, this is our linked list and we have to insert E. Stop at the node after which you have to add. Say, here you want to insert between B and C. So stop the iteration once you reach B and then do as below. E.next equals B.next. B.next equals E. Deletion in the linked list. Take for instance, this is our linked list and we have to delete C. Maintain two variables for the current as well as previous node, and then do previous.next equals previous.next.next. Basically, we want to store the address of next to next element into the previous element. That is, assigning the address of next to next node of the previous to the next of previous. That would simply delete that particular element. Hope you guys enjoyed this video. That's all from the linked list for today. We will cover the other functionalities like reversing the linked list and some more problems in the links in the next video. Hey, Wait, have you subscribed the channel? Don't forget to subscribe this channel. Like, share and subscribe our channel and do support us by commenting. See you in the next video guys.